Hey guys, welcome to another piece of vintage test equipment. This is a beast. This is an acquisition that was sometime in the making. What it is, well, it's very deep, it's very heavy. It is a Hewlett-Packard 8664, although mine is actually branded Agilent on the front. It says HP in other places. This was introduced in 1990. I think mine was made a bit later than that. No more when we get inside and check the date code. So, I'd actually been working on acquiring this for some weeks, but I didn't want to mention it until it was actually in my possession. I got it dirt cheap, but I had to get it shipped to me. Unfortunately, it wasn't the same place I got my 8662, and they did not pack it very well. They ended up just going to UPS and having them pack it. So they wrapped it in a ball of bubble wrap and put it in a thin-walled cardboard box. Not surprisingly, it was damaged. Both these feet broken off, sheared off the bolts, damaged the aluminum frame a little bit. What's worse is up front, the RF connector is bent off to the side. So why did I get this? Basically, it was a deal too good to pass up. It is the successor to the 8662. So it's about 10, 11 years newer. It has similar specs, and it's a synthesized RF generator. The 62 can go to 1 gigahertz. This can go to 3. But this only has 3 markers. The 62 has 5. But similar specs in terms of the accuracy, the low phase noise, great options for AM, FM, and phase modulation, and so on. It came out of a lab, the Elmo lab. The seller, all they could say is it turned on. But I've had pretty good luck with that in general. Yes, sure, there are some shady sellers out there who will say, oh, it powers up and I was unable to do further testing. And they know full well what they have, what it can do, and they know it doesn't work. But often the case is that legitimately they don't know what it... no means of testing other than turning it on. So I took a chance. Cosmetically, aside from the shipping damage, it's in beautiful condition. We're looking at the back side because it's got knocked around. I want to open it up before I turn it on and make sure that nothing got dislodged or damaged, or like the 62, there were burned or charred traces on the thing. I mean, clearly it had issues, so I want to make sure that this is sound before we turn it on. It is over 2 feet deep and weighs about 80 pounds, hence the caution. I can lift it. It's not a lot of fun. It's crazy big. Even if this worked flawlessly and does everything that I could ever want it to do, it's a bit deep to keep up on the workbench. I could put it below maybe and run cables, but that would be super awkward with programming. So I'm not 100% certain what I will do with it. But for now, we're going to have some fun with it. I've had a little trouble finding the so if you go to Agilent.com, they have a whole area of archived owner, operator, service manuals. And they have this, but it's not all the pages. There are 4 sections. It goes up to, I think, halfway through section 4 or 3 or something, and then stops, and there should be half a dozen appendixes. The first one, Appendix A, is how to turn this on for the first time, how to unbox it, hook it up, and put it through its paces. I'm missing that whole section. So I'm just gonna, and there's very little info about this online. I found a few YouTube videos, so we'll just wing it. Well, it does appear to be some type of torque, so I still don't get to use my POSIDrive, a new POSIDrive tool. Let's see if this guy will fit. Oh, too big. Maybe a T15. Yep. Let's see if this little handle will give me enough torque. It's a little hard to find info on this device. There's a whole family of them. If you go to the Agilent website and their archives, they do have the owner service manual for this, but it's missing all the appendixes. And Appendix A is how to first power it up. The pages they do have are just kind of a beginner's guide to how to use a signal generator. No service info, no schematics, not much of anything, just kind of generic info. So that's a little disconcerting. Well, I'll take off. These are Torx bits too. Yeah. So I'm thinking if I take off the top and bottom screws on the 4 feet, maybe this entire thing slides back. That would be good. There's a few videos on this device. One nice one shows how to go through all the internal calibration procedures. So this certainly has a more advanced onboard computer than the 8662, and it has secret modes you can get into to run self-diagnostics. The 8662 does not. A few of you have said, hey, maybe you can run through diagnostics on the 8662. No, it's all, you got to pop it open, get the extender cards, and put it through its paces with external equipment. And there's this thing that sticks down below. Oh, maybe. I bet that's an aid, so you can pull on this to get the cover off. I was thoughtful of them. There's also damage on the front. In particular, the main RF out jack got messed up. Oh, it's not doing anything. It could just be because of the weight of the devices on it. But I don't know. All right, let me see. I'll struggle a bit with this and resume hopefully when I have it open. I flipped it on its side and discovered there are 2 small screws underneath this pull-out handle, smaller Torx bits, so I'll try getting those off. But while it's on its bottom, I'll show you the other damage. I also noticed there are a couple screws up here that say do not remove. There's the RF connector. This corner got smashed, and this is heavy gauge aluminum, so you can imagine it took quite a, I'm sure it was dropped on this corner. And the RF connector got the brunt of it. It's an adapter I put on in the hopes that I'll be able to get something out of it, but this is how it arrived, just like this. Not good, not good. Alright, so I'll get these out and see if I can slide the cover off. Did a little more searching, and this time I searched for Agilent 8664A, and I did find a newer service manual from 2000. Doesn't have schematics, but it has detailed block diagrams, theory of operation, and disassembly instructions. And unfortunately, yeah, I think there are 48 screws you have to remove. 14 on top, 14 on the bottom, and 7 on each side. They all got to come out. So I'll get to it. I think I will switch to a motorized device for that. Not much fun, but they do come out easily enough. And then the piece of metal underneath will just come away as 4 pieces. Okay, got them all out. There was double-sided adhesive with this grayish pebble plastic sheet over some of them. The top piece was missing. I'll leave it off, but I wonder if somebody sells replacement strips. Yeah, it's kind of coming. Yep. It's just not much to hold on to. Okay, once you get it going, it's a little bit easier. There we go. Crunching sound. So paper tags on all the cables. They do have an elaborate interconnect diagram in the service manual showing how all the cables go. I suspect since this thing got bashed around a little, this doesn't slide as easy as maybe it did originally. This is so deep, I can't even keep it all in frame. There we go. Oh my God. Wow. So, if you thought the 8662 was a trip, which it is, this takes it up another level. Somewhat similar idea. Well, not somewhat. It is the same idea in that modular, bunch of cards, whole bunch of interconnects, onboard computer running everything, which apparently is all the way back here. Let's see, date code. Not sure how to interpret these. 2068. It can't be the 68th week of 2000, so it doesn't make any sense. Well, these chips are upside down making it. Okay, 9845, okay, 1998 45th week. That one we got. I'm just going to say late 90s. 9903. And a very fancy looking analog devices chip. Alright, let's go in closer for a flyby tour. So let me start out by saying I have no intentions of attempting to repair this. I'm not pulling boards out. If it doesn't work. It's funny, while researching this, somebody posted a video on a similar device from a year or two ago, and they said that they asked Shango for advice, and Shango's advice was, if it doesn't work, find another one, rather than attempting to repair it. But he didn't repair his. He just bought some new cards and just replaced the entire cards based on the error code. Very basically what I did with the 8662. Look at the error code, figure out what module's bad, and just replace the whole thing. So this is not the entire computer. This is just interface stuff, I think. An Atmel 28. I think it's just a ROM chip. EEPROM maybe 2864. What is it? 8573. Isn't that a true RMS converter? Maybe, or maybe it's a ADC or DAC. There's a lot of pins for just a true RMS converter. So, what do I know about this device? I believe it came out of a lab, a working environment. The seller just said it turns on. It needn't have any further means of testing, which is the kind of stuff I like to go for. Yeah, there are unscrupulous sellers who may full well know that it has error codes. But more often than not, especially if it's not a vendor that specializes in test equipment, if they say they don't know how to test it, they very often don't. They can just plug it in and turn it on and see what happens, and that's all they know. It must be a pull tab. So what is this huge thing on the side? I don't know. I know somewhere in this is a crazy, accurate oscillator, reference oscillator. I forget the acronym for it, but it uses a ball of a special type of metal suspended in a a magnetic field or something like that, and it resonates and makes a very, very, very precise oscillator. This thing is accurate to 0.01 hertz. 3 gigahertz at 0.01 hertz. That's a whole lot of digits of accuracy. And the phase noise is ridiculously low. So yeah, it's a bunch of sealed metal boxes with cables between them. Fewer adjustments in this device. It's newer, it's more digitally controlled. As I said, it can calibrate itself, which is kind of interesting. So we don't have all those trimmer pots and such like we do in the 8662. There is hundreds of pages of doing the self-test and all the built-in calibration stuff in the service manual. Let me flip this over. I want to check the power supply area in particular to look for anything being bad. From the top, this looks fine. I don't see any shattered boards or cables that popped out or anything that would cause me any concern. All right, it looks like it's never been opened before. The fact that all these screws were still sealed, it had the calibration stickers on it and everything. This has probably never been opened since it was made. Fortunately, you can't see a whole lot on the bottom. You can see the bottom of all the sealed metal boxes and the bottom of the power supply. So here's some big old electrolytics in here. So this is roughly 24 years old or so. Practically new compared to the vintage electronics I usually work on. And they used top grade parts. So there's a pretty good chance that this power supply is just fine. It'd be nice if I could see the top of it and look for any bulging caps or discoloration or anything, but when I look at the bottom, nothing's vented. We don't have charred traces like we did in the 8662 that had obvious signs of distress. And it smelled a little roasted even as well. So I'm inclined to give it a try. It has a fuse. I'll plug it into my PR57, which has protection as well. Because as you can see, there's only so much I can do, and I don't really want to take this thing apart. So let's give it a try. Okay, let's give this a try. Let's turn on the PR57. This device is turned off right now, but I suspect it's going to draw some standby current for the crystal oven. Here we go. Oh yeah. That's drawing about 0.5 amp actually. And standby. Curious if that'll drop off as it warms up, stabilizes. It's a lot of standby current. It's maybe slowly dropping. Holding fairly stable now, huh? Alright, let's give it a try. Increase the current range on my device. Not as much as I thought it'd be. It's drawing about 2 amps. Wow, and it is all lit up. Amazing. I really wasn't sure what to expect. I did see one guy, the guy who was talking to Shango about his, and his did the same thing. Went into calibrating, and it sat there, he said, for 12 minutes. And he said that's an indication that the battery buried somewhere in this that keeps, I guess, a static RAM. It keeps its memory intact when you turn the device off. That the battery's dead and needs to get replaced. I have no idea where that battery is. I don't recall seeing it. I'll have to review the footage or look at the service info. I'm not looking forward to taking the cover off again. Even without the screws. Probably because it's dented a little bit, this cover was not easy to get back on. Alright, so what do we see? Calibrating with a little thing going back and forth. Oven, MSSG, mod, off, off. Audio, RF off. Buttons don't do anything. I'll just let it sit. Well, now that certainly looks promising. That's crazy. What are we looking at? 1,50000. That's so 1.5.00 gigahertz. I guess. In other words, 1,500,000,000.00 megahertz. Yeah, the knob seems to work. Oh, that's insane. I can go using the knob and go in 0.1. I don't know, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's like 12 digits of accuracy. That's ludicrous. As best I could tell from looking at the service manual, that these were intended for high precision communication receiver work. So it has fantastic AM, FM, and phase modulation, where you can control the percent modulation, the bandwidth, very, very precise. I notice it has an audio out on the front. I don't know if that means you can get the modulation signal output on the front. I just have a sketchy knowledge of how to use this. It's similar to the older devices, it just has more stuff. So that's our RF out. It says RF off, and that's smashed. Hopefully that's still working. And that's the knob. It doesn't work on my 8662, but the way it should work is, depending on which mode you last touched, amplitude and modulation frequency, this controls it. And these buttons up top control which digit you're going to change. So not what the top digits go down. So it's just kind of how HP chose to do it. And there's the numbers you input, and then you can choose gigahertz, megahertz, kilohertz, hertz. Output levels, we have modulation, AM, FM, pulse. There are various optional modules. I don't think I have the pulse. That's why there's a blank for that. These are just protective caps over the BNC, so we have external AM, FM, phase modulation. So, if you've been watching my vintage TV alignment series, I talk about the video is AM, the sound is FM, the color is phase. I think theoretically with this device we could cobble together a video signal. We would need to get sync pulses from somewhere, but in terms of we could feed a video signal into the AM and sound into the FM and color into the phase. Oh, but you can't do separate carriers for each one. Oh well. At least individually we could do various components. Comprehensive sweep thing here, so we can do start, stop. So it's starting it. Maybe they wanted to show this thing off because it's going the whole range. The start frequency is set for 10 kilohertz, which is the lowest this will go, and it goes all the way up to 3 gigahertz. So right now, if I turn on sweep, it'll sweep from 10 kilohertz to 3 gigahertz, which is kind of crazy. And it looks like there's only 3 markers, whereas the older 8662 has 5 markers. Display special recall save sequence. I'm not sure what any of this stuff does. Of course, it's got GPIB. That's what this little section here is for. I have no idea what any of this stuff does. So let's dial in a more modest frequency. Let's do 10 megahertz. Well, the button says RF on off, so how about we try on? Mine is 140 dBm. That's probably the lowest this can go. Let's try 5 dBm. No. Oh, wrong button. Amplitude 5. Ooh. It's a very satisfying clunk. There must be some type of solenoids in there or something, but it says on. Or, well, I mean, it doesn't say off anymore, right? RF off, now it says 5 dBm. Well, let's hook it up to a scope and see. Why am I in 10 gigahertz? Or no, it's 0.01. I don't know. Let me try putting in frequency again. 10 megahertz. I don't know why it was saying 0.01 gigahertz. Whatever. And this is why I pulled that adapter out. I was hoping that this would have some life left. But I don't know how I'm going to straighten out this connector. Yeah, I can get the cover off, but I need to get this front panel apart. If it works, I'm inclined to just leave it as it is for now. So, BNC terminated. I'll just clip my scope onto that. I could just go BNC to BNC straight into the scope, I suppose, but then I wouldn't, well, yeah, I wouldn't have the proper 50 ohm termination. Well, there's something on my scope. Let me turn off these floodlights so you can actually see it a little better. Let's see. Change the voltage. Oh yeah. Ooh, look at that. Look at that. Let's see if we can, well, try some stuff. Let's do amplitude, and I'll use the wheel. That's so satisfying. And I love the clunks as it goes through the coarse range. Oh, there's several. There's a really loud clunk, but then there's some subtle ones in between. Maybe they're reed switches. That is very nifty. Okay, how about let's try doing the same for frequency. Oh yeah, let me try a less coarse. Sure, we can change frequency. Very nice. Okay, how about the all-important sweep? Well, let's just put it on auto. It's going through the whole friggin' range. I can't even tell what it's doing. Time sweep. So it's doing a 1 second sweep. Looks like the fastest you can go is a half second sweep. So that's sweeping from 10 kilohertz to 3 gigahertz. I'm thinking maybe it's tapering off because my scope doesn't have anywhere near the bandwidth to see all that. I don't know why there's such a big gap in between sweeping. Well, let's try changing start and stop frequency. So for a vintage TV, I would typically want to sweep from, say, 20 to 30 megahertz. So let's give that a try. So that's the problem with my other sweep gen HP, is that the amplitude varies as I'm trying to sweep. Alright, there's 20 to 30 megahertz. It looks like the output level's pretty consistent. I think that's some kind of retrace blanking interval when in between the two. I'm not quite sure what that's all about. But when it's actually sweeping, it looks like it's pretty darn level. So I'm going to try playing around with the sweep time. Now it's 5 seconds to do the sweep. Oh, it turned off. That's not cool. Everything seemed to be working fine, and I looked down and it was just off. Huh. It's back on now, though. Maybe I bumped into the power switch as I was leaning over everything. I hope so. Fan kept running. It saved my settings, so it didn't turn off, really. Oh, yeah, so... Oh. It's when I lean on it. Or something. That won't turn back on. The fuse, I put it on its side to check the fuse. The fuse checks fine. I turned it back on and it came up, but now it's going through the calibration procedure again. So I think my gut feeling about something getting whacked in shipping was maybe I'm onto something. And yeah, it was pretty clear that, 2-3 times I leaned on the case in a certain spot, and that's when it took a nosedive. So maybe I was pushing on something that caused him to short out, and maybe a regulator was overheating and turned itself off. And then it needed a minute or two to cool down to start working again. Back in business for the moment. Back to factory reset settings. I'll let you guys watch the scope while I set it back up. So let's do 10 megahertz. Let's see. RF on, amplitude. Oh, there we go. Good. For the moment. Let's try some amplitude modulation. AM internal. Do 50%. Oh yeah. Oh yeah. Cool. Some lovely AM modulation. How about some FM modulation? It's off. FM 50 kilohertz. FM. Is that right? It's on. Oh yeah. Okay. You can see how it smears out towards the end there. It's a clear indication that frequency modulation is working. Okay, let's turn that off and try to sweep again. Start frequency 10 megahertz, stop frequency 20 megahertz, sweep time 1 second, that's fine. And auto. Well, that's sweeping. Rather clunkily. Output levels varying a bit. The other generator lets you specify how many steps between the two frequencies. I'm not seeing that on this. Center, sweep time. Let's try a little bit bigger span then. Keep the 10. Let's go 10 to. I want to go 20 to 30 now. Right, whatever. I'll do 10 to 40 megahertz. How about that? The output level is varying a bit. Could it be that that's just how these generators are when they do digital stepping with these synthesized generators, that the output level varies a little bit? Well, they're both doing it, and neither one has error codes. I'm playing around with changing the amplitude. See, what I'm wondering is, I think normally when people sweep with these, the way they were intended use is they're sweeping over a much wider range. Like the WaveTech 1080, by default it sweeps over its full range from, let's say, 1 megahertz to 1 gigahertz. That being said, I'm picking up excuses for them. This device is supposed to be super accurate and have outstanding performance, so I imagine that output level isn't supposed to vary as it changes frequencies. So let's try what I did with the other device. So forget about sweeping, let's manually change the frequency and see if the amplitude changes. We're at 40 megahertz right now, and I am lowering the frequency, oh, no, hang on. Still learning the ins and outs of this. Okay, we're at 10 megahertz now. Oh yeah, the output level is absolutely varying as I change the frequency. What the heck? Could it be my scope isn't working as well as I think it is? If I go slow, it doesn't seem to be jumping. When I was going fast, it was. Maybe I wasn't giving the device time to settle down. Yeah, if I do this oh no, okay, now it is dropping off. I don't think it's my scopes. Yeah, now it's increasing a little. Oh, it's increasing a lot. Ah, boy, I don't know what to think now. Through here, I'm varying it from maybe 14 to 15 megahertz, and there's a noticeable dip and then it goes back up. What the heck? Well, so I will go through the internal calibration procedures on this. Also, just want to let it run for a while and see if that problem comes back where it turned itself off. So, as you've seen my experiences with these two devices, I by no means recommend any of you run out and buy these 30, 40-year-old devices. They were amazing in their time when they came out. They cost a small fortune when they came out, and the buyers were generally labs and whatnot that had deep pockets, and they would regularly have them serviced and recertified, recalibrated, and so on. To buy one for $100 off of eBay or at a swap meet or something, just be prepared what you are in for. You may end up spending far more money and time than they're worth. To give you some idea, a reputable used equipment seller has one of these on their website for sale that's been recertified. It's $1,800, I think, or $1,900. So between these two generators, I've now about $1,000 sunk into it between buying the devices. A lot of that was shipping, and then buying replacement parts and a board for the 8662. If I start recapping this or doing work on this, I'll easily spend a few $100 on that as well. So by the time I could, assuming I can get these both working, I will probably very likely spend more than I could have just bought one of these for that's already been serviced. So that's also something else to consider. Final thing to consider is just buy a new one, if you can afford it. And of course, this is gross overkill for anything I'm doing. You can get more budget-minded. They have amazing devices out there. They practically have this whole device on a single chip these days. And you can get them for $100 or so, a direct digital synthesized. The problem with the ones I've seen is they're like that tiny SA. They're in little plastic cases that are flimsy. They don't have a nice big control panel. They don't have good output attenuators. They're kind of like toys. Yeah, they have the great hardware inside, but they don't have the great packaging. They don't have a robust power supply and connectors and all that. I haven't done a lot of research. Maybe there are vendors that do, and if you know of one. So it seems like you either spend 10 grand or $100. There's got to be something that's a few $100s that's has nice features and a decent enclosure that can do basically what this does, or some of what this can do anyways. But it is, I find this interesting to play around with, but again, this thing is huge. It is very cumbersome to do anything with. Even just to check the fuse is awkward. And getting the case open and all that. But if you're curious to see what 1990 or 1990s tech was like, top of the line, synthesized RF generator, there you go. Beautiful vacuum fluorescent display. But if any of this, like say one of these displays had shattered on shipping, forget about it. Yes, there are people that have parted these out and they sell them on eBay. I'm not saying you can't fix it or you can't get parts. It's just going to start costing you more and more and more money. So my plan is to get the 8662 working well, and I want that to be my main, and I'll keep this as a backup. Or maybe for some more exotic projects I'll want to use both of them. But my main intent was to do sweep and radio alignment, and I like having 5 markers, and I like that the front panel is a little bit more compact on the 62 versus the 64. But that being said, this is an absolutely gorgeous device. Beautiful display, the feel on these buttons. The front panel on this is immaculate. The wheel is great. As long as it stays on and keeps working. But boy, I am really curious about that output level varying. I'm just turning the frequency knob. Why is it dipping right there and then going back up? So like I said, I got to read more about this. There is a mode in the 62 where you can turn off some of the amplitude leveling stuff. Depending on what you're trying to achieve with the device. But I'm pretty sure it's enabled by default, and I would think that this would have been on. This doesn't vary as much as the other one, but there's a dip there. And there's a lesser dip around in here. Huh. Anyways, that's going to be it for now. I hope you enjoyed this look at I guess it was introduced in 1990, but they made them for a decade or more. Hewlett-Packard 8664A, 3 gigahertz, synthesized RF generator.